Okay, so I want to talk about the graphing method for finding the solution to a linear system. Method 1 graphing. I'm on the front of our notes here. Hopefully you're all following. We're on the front of our notes. These are the steps. Graph both equations in the same plane. So in that same graph, you're putting both lines, or all lines, there may be more than two. Estimate the point of intersection. Now I'm saying the word estimate. Why am I saying that word when I should just say find it? And we'll look at some examples later to see why we only estimate them. Step 3, and you're going to now take your pencil, or if you have a highlighter, and you're circling step 3, and you're making stars by step 3, and you're making exclamation points by step 3. Is step 3 important?
Probably.
I don't think so. Check step 3. Check your estimate by substituting coordinate values back into both of the original equations. This is an estimate. When you look at the graph, you're like, I think it's here. You have to check it by plugging that point back into all the equations in your system. So let's look at this example. 3x minus y equals 2, x plus y equals 6. So step 1 says, graph both equations. We have choices how to graph. If you want, you can use the intercept method. Sometimes that's easier. I like y equals mx plus b, slope-intercept graphing. So we're going to subtract the 3x so that it's now on the other side. And now I've got negative y equals negative 3x plus 2. How do I turn a negative y? I don't want negative y. I want y equals. How do I do that? We divide or multiply each side by negative 1. So what happens when we do that? What happens? Yeah. So we actually see the signs flip, right? The signs will all change. Okay. So there's our first one. What's our m? What's our b? What's our m? Good?
3.
3. What's our b? Our y-intercept? Go ahead, you can finish it. Negative 2. So tell me, how do I graph this?
You put the 3 over 1.
Okay.
And
Where do we start?
you start at 0.
No, where do I start?
Oh, negative 2 over 1.
We start at our y-intercept always, right? And then what are we doing here? We've got a 3 over what?
Up 3, right 1.
Up 3, right 1. 1, 2, 3. 1, 2, 3. What else could I be doing? I went up 3,
yeah.
right
You
1.
go down 3, left.
Down 3, left 1. Now when I do these, I like to fill my graph, the whole graph, because I don't know where that point of intersection is going to be. So I want to have a nice big line. That's the first one. Great. Now let's do the second one. I still want it in y equal form, so I'm going to subtract the x to the other side of the equation. What's my m and what's my b? Go ahead, what's my m?
Negative 6. No, negative x. Negative 1.
Negative 1, there you go. This one's a tricky one. You don't see it, but it's there, right? There's that secret 1 over there. And what's my y-intercept? Negative 6, great. How do I graph it?
Negative 1 over 1. Then go to negative 6 on
1, 2, 3, 4, 5, 6. Make sure I'm in the right spot. Yeah.
And then you go down 1 and then to the right 1. There you go.
Down 1, right 1. What else could I do?
Up 1 to one and 1 to the left.
Up 1 to the left 1. So I am seeing my line here. Did you have a question?
Yeah, can you do again? Equations for right now.
Which one?
Equations for.
Which part do you want me to do again? I just know. Which step is the problem? This one? Did I just copy this right here? This is the same as that. And then I subtracted x from both sides because I want to have y equals. So this becomes y equals negative x minus 6. And then secret 1 here. So my slope was negative 1. where did this equation come from?
No, I was asking where did the subtraction sign come from?
The subtraction sign, because I want to subtract that x.
Yeah, but
It's right here.
Oh.
Yeah, it's a negative right negative. Okay, just didn't see that guy. Okay, so all this work we just did, step one, it's a lot of work. Step one's a lot of work. Let's look at step two now. Estimate that point of intersection. Now, I'm not the greatest line drawer. My line kind of is off a little bit. But what would you say is an estimate of that point? What would you say? -1, -5. That is my estimate, my guess. Now, how do I know if my guess is correct? What do I do?
Oh, I thought you put X and put it where the X is in the equation, so Y.
Here, yes. I'm going to take this xy and I'm going to put it in the original equation. Now, why am I putting it in the original equation? Why don't I put them in these equations over here, which are actually a little bit easier to work with, because I could just plug the x in and I get a y out. Why would I go back up here, which I'm going to insist that you do when you verify back into the original? Why? Why do you think?
Check your work and right?
Check my work? Well, I can check my work by putting it here. Why do I have to go back up into this one to check it? I can check it with these. What do you think?
That's the original equation.
So?
You should, I guess check it with the original, because you could change something on accident.
I could have done what by accident? He's being nice.
Something.
I could have messed it up. I could have done something wrong. He's just being nice. Mrs. Grieser never does anything wrong. Oh, yes, she does. Anybody ever make a mistake going to y equal form?
No.
Oh, who's not raising their hand? Oh, yes. Everybody.
I never made a mistake.
So let's say you made a mistake, except for you. The rest of us have made mistakes sometimes when we put in y equal form. So we don't want to, if we did that, we'd be solving a different system. How would we catch it? By putting it back in the equation. So let's do a quick check. My first equation is 3x minus y equals 2. Be awfully careful now. I've got a lot of negatives. When you replace, use these little parentheses signs so that you keep the signs correct. So -3 minus is a
Positive.
yeah, plus 5. -3 plus 5?
Yeah, I think the two.
2. Excellent. Great. So this one works. Let's go try the other one now. X plus y equals -6. So my x is -1. My y is -5. -1 plus -5, that's -6. Woohoo!
I put it as -1 minus 5.
Which is fine, that's equivalent. So is this solution correct? Yes. Yes, it is. I'm just going to erase this for a minute to show my point underneath here. So, again, you might want to write this down. In fact, you definitely do. Always verify the solution in both. You're going to want to. You'll see. It's almost human nature. You'll see it work in one, you're going to stop. Very often, it works in one and not the other. Question?
I only did the substitution in the one that's in white.
It's going to work if you do it right. You're right. Now, this is fine to use if you made no mistakes. How do you know you made no mistakes? You kind of don't know. This one I know has no mistakes in it. That's why I'm using these. It will work in these if you did it correct. Question?
Are all the math units specifically planned out like we need to learn slope for variation that we need?
Yeah, you see, yes. I mean, they're meant to be progressive. We learned all about slope. We learned all about graphing to lead to this moment, right? We couldn't do this without slope, without graphing. You're right. We do that. Other questions about using this graphing method? Yeah.
I want to do this on a checking.
Okay, what I'm doing when I'm checking? So I take my point, right? -1, -5. I'm going to plug the x here, and I'm going to plug the y here. They're negatives, So I have to be really careful when I plug them in, but I did, I got 2, which equaled that side. Now I have to check the other equation. So I put the -1 in here, and I put the -5 in there. So basically it says add them, and you should get -6. Add them, I do get -6. So I'm just verifying it makes both of these equations true. Great, other questions? Fantastic.